Hi, AB students. I'm making a video on figuring out the derivative of e to the x. So let's take a look at that. So the question is, what is the derivative of e to the x? In this video, we're going to find what the derivative is and prove it. So first of all, we're going to need two tools. The first tool is the definition of the derivative. Here's the definition. And then the second tool is what's the definition of the number e. So the number e, it's the number around 2.71, and by definition, e is a number to make this limit equal to 1. So you can already kind of see that this formula looks something like this formula, and we're going to need both pieces working together. So let's actually get on with the proof. So what we're going to do is we're going to prove that the derivative of e to the x actually equals e to the x. That's the goal here. So here's the proof. First of all, let f of x e to the x, then I want to check out f prime of x. Let me move this up. So by definition, f prime of x will be a limit as h goes to 0 of f of x plus h minus f of x divided by h. That's just what I wrote on the last sheet of paper. Now, what is f of x? F of x is e to the x, so this will be the limit as h goes to 0. F of x plus h is e to the x plus h. F of x is e to the x divided by h. Now, you stare at this, and there's not so much you can do, but you see you have e to the x plus h. Think about rules of exponents. E to the a plus b, this should be e to the a times e to the b. So this could be useful if we use this sort of idea here. So I'm going to get limit as h goes to 0 of e to the x times e to the h. A plus in the exponent makes a times here, minus e to the x divided by h. And at this point, what should you do? Well, you have a common term e to the x in both. Let's factor that out. So I'll have limit h goes to 0 of e to the x times e to the h minus 1 over h. Now think back to our two definitions on the previous page. Here they are, and look at the definition of e. E is a number that makes this limit equal to 1. But hey, this limit also appears right here in our proof. So that means that this piece I've circled right here, that goes to 1 as h goes to 0. That means that this whole thing is getting closer and closer to just that piece that's left over. It's going to look like e to the x times 1. In other words, just e to the x. So what we've shown is that take the function f of x equals e to the x, then f prime of x also equals e to the x. So we've proven the theorem. So this is the end of the proof. I'll make a little box because that's the end of the proof. Great. So in other words, e to the x is its own derivative. That's what we just showed. If you have f of x equals e to the x, then f prime of x is also equal to e to the x. So let me show you a little example. How would you actually use this in practice? So here's an example. Find the derivative of e to the 2x. And I want to do this with just the product rule. I don't want to use the chain rule yet. So the way I'm going to do this is first I'm going to rewrite this as e to the 2x. That's the same as e to the x times e to the x. So again, here I'm just using the exponent rule that we used on the last page. At this point, I want to use the product rule. So I'm going to use the product rule here. Product rule says to figure out the derivative of a product, first take the derivative of the first one, multiply it by the second one, then take the first one, which is e to the x, times derivative of the second one, which is e to the x. But hey, the derivative of e to the x is also just e to the x. So we're just getting e to the x here times e to the x plus e to the x times e to the x. Okay, so now at this point I could simplify it. First of all, I could write this thing as e to the 2x. Like here we went backwards, we wrote e to the 2x like that. Well, I could also write this as e to the 2x. So I have e to the 2x plus e to the 2x. And then this is equal to 2e to the 2x. Okay, so we just showed in this example that the derivative of e to the 2x is equal to 2e to the 2x. And more generally, what do you think the rule should be? Well, it's that the derivative of e to the kx is going to equal k e to the kx. And this is actually, if you want to prove this without product rule, we use product rule here. This actually follows directly from chain rule. If you don't like chain rule, though, you could prove it just as I did up here. So the takeaway from this video is that I gave a proof that the derivative of e to the x equals e to the x. Thank you for watching.